question 1, we have a mass balance problem related to strawberry jam production. We have to analyze the question first. The strawberries contain is 15% of solids, which including sugar, and 85% of water. And the question mentioned that equal masses of crushed strawberries and sugar are mixed in a mixer. The mixture is heated and passed through an evaporator to remove water. And the final product, which is strawberry jam, contains 25% of water. So this is my process flow chart for the question. We have the inputs, which are strawberries that containing solids and water, and also sugar. We have mixer, which the function is to combine strawberries and sugar together, a heater, which heats the mixture, and evaporator to remove the excess water to achieve the desired composition. So right now, at the output, we have final strawberry jam containing 75% solids and 25% water. Right now, we have to do the mass balance calculations. So we assume that the mass, before that, the total input mass must equal to the total output mass. So we can assume that the mass of strawberries is equals to the mass of sugar. Next, we have to define the variables. So right now, I'm making m strawberry as mass of strawberries and m sugar as mass of sugar. Next, we have to do the sugar balance equation. The total solid content in the final jam must be 75%. Okay, so the solid come from the strawberries, which contain 15% of solids, and the added sugar, which is 100% of solid. We can conclude that 0.15 times with m strawberry plus with 1.0 times with m sugar is equals to 0.75. That will be our first equation. So for the water balance equation, the water in the jam comes only from the strawberries, since sugar does not contain any water. So the final jam must contain 25% of water. So we can write it as 0.85 times with m strawberry plus with 0 times m sugar is equals to 0.25. And that will be our second equation. And we can express one variable in terms of the other. We can rearrange the equation 1, and it will be m sugar equals to 0.75 minus 0.15 m strawberry. So that will be our third equation. So solving for m strawberry, we got m strawberry equals to 0.294 pound, and since m sugar is equals to m strawberry, we also can conclude that m sugar is also equals to 0.294 pound. So right now, it already answered the question. We need 0.294 pound of strawberries and 0.294 pound of sugar to produce 1 pound of strawberry jam. So to answer question C, first one is equipment costs. In a large-scale commercial operation, industrial-scale mixers, heating systems, and evaporators are required to process large quantities. So these machines involve a huge investment and operational costs. So for the second one is quality control. For example, the jam must meet food safety standards such as hygiene regulations. The third one is labor requirements. In a commercial setting, a larger workforce is required for example, handling raw materials and operating and maintaining machinery. And the last one is supply chain management. This means commercial production needs bulks of purchasing the products. Okay, for the second question, we have a mass balance problem involving two methanol water mixtures that are combined in a mixer. So for the first step, we have to understand the problem statement. We are given two separate methanol water mixtures. So for the mixture 1, it contains 30% of methanol and 17% of water. The total mass of this mixture is 250 kilograms. So for the mixture 2, it contains 60% of methanol and 40% of water. The total mass of this mixture is 200 kilograms. So these two mixtures are fed into a mixer where they combine to form a final product. So right now, our goal is to determine the total mass and composition of methanol and water. For the second step, we have to draw the process flow chart. So this is my flow chart that I drew. We have two input streams, which are mixture 1 and 2, that enter the mixer, and one output stream exits the mixer containing the final combined mixture. So right now, we need to find the mass fractions of methanol and water in this output stream. Okay, for step 3, we have to do the mass balance calculation. Now we have to find the total mass of final mixture. Since no mass is lost in the mixer, the total mass is simply the sum of both input streams. Total mass equals to 250 plus 200, which equals to 450 kilograms. Then we have to calculate the mass of the methanol in the final mixture. So we need to calculate the mass of the methanol from each of the mixture. Methanol in mixture 1 is 0.30 times 250, which equals to 75 kilogram, and methanol in mixture 2 is 0.60 times 200, which equals to 120 kilograms. So the total methanol in the final mixture is 75 plus 120, which equals to 195 kilograms. Since the total mass is 450 kilograms, and we already know that the total methanol is 195 kilograms, the remaining mass must be the water. So mass of water equals to 450 minus 195. That means it equals to 255 kilograms. So for the next step, we have to calculate the composition of the final mixture. We have to do the X methanol is equals to 195 over 450 times with 100, which makes it 43.33%. For the water, we only have to calculate like X water equals to 100 minus 43.33, which equals to 56.67.
I'm going to continue the question for number 3. They give us for the equation. First question is calculate how much methane was consumed. And kita kena cari fractional conversion of methane. Here first we need to find the methane that consumed. We have right here the 100 mole for methane. We have 40 mole for methane dekat bahagian product. We need to find the consumed one, 100. Need to minus with 40 methane that in the product side. So we got 60 mole. Then kita ada formula for fractional conversion, which is a CH4 that consumed and need to divide with CH4 dekat bahagian feed. I'm so sorry sebab masa kat sini CH4 kita dah dapat consume dia tadi 60 mole divide with the dekat bahagian feed punya which is 100. So 60 bahagikan dengan 100 and then you're going to get 0.6 mole. Next kita pergi dekat soalan B. Calculate how much oxygen that consume. Okay, that the same question but the different dia punya bahan lah which is the oxygen. Kita ada dekat bahagian feed 250 and bahagian product we have 130. So in this equation tu we have 2 depan O2 dekat sini. So 2 ni need to times with Z. Why we need to times with Z? Like the equation for O2 is like this. This is equation for O2. Like you can see here, kita nak cari dia, kita ada 250 minus with 2Z1 is equal to 130 mole. Daripada equation O2 tu, kita akan dapat macam ni. Dia kena times with 60. Sebab tadi kita dah kira untuk Z ni, kita dapat Z1 is equal to 60 mole. So that's the reason why dekat sini equation tu, you just masukkan balik 250 minus with 2 and times with 16 and you got 130 mole. So you kira, you akan dapat the answer for O2. You akan dapat 120 is the consume for O2. Nak kita kira fractional conversion. So fractional conversion tadi kita tahu dia punya formula that consume dekat feed. Consume dia 120 and then we need to divide with 250. Dekat bahagian feed dia kat sini you boleh tengok 250 bahagikan and you're going to get 0.48 mole for O2. For the question C, dia nak kita write the reaction equation. Kita kena buat satu persatu. Kita kira for methane first. Sebab kita tengok dekat sini bahagian ni ada methane, ada oxygen, ada CO2, ada H2O. From here, you kena buat satu-satu. Like CH4, dia punya equation is 100 minus Z1. Z1 tadi kita tahu, kita dapat tadi Z1 is equal to 60 mole. So 100 minus 60 mole, kita akan dapat 40 mole for CH4. O2, kita punya equation 250 minus 2 times 60, kita akan dapat 130 mole for O2. And then we have CO2. CO2 here, dia punya equation is Z1 is equal to 16. Macam mana kita nak tahu equation is Z1 je? You tengok dekat equation that given right here. Right here, equation given. Dia dekat bahagian product, right? So, dia akan plus Z1. So, that's the reason. Dekat sini plus Z1. So, Z1 tadi kita kira dapat 60 mole. H2O. Dekat sini H2O right here. From the equation here, H2O is equal to 2H2O. So 2Z1. So 2 times Z1, Z1 kita dapat kat sini 60 mole. So 2 times 60 mole, kita akan dapat 120 mole H2O. So this is all for question C. So this is all for question number 3. I'm going to explain about question B. Question B is asking for carry out the degree of freedom and then analyze and calculate the molar composition using the molecular balance. So this is the flow chart. And the degree of freedom, how to calculate the degree of freedom? Firstly, we need to know the number of unknown. So number of unknown here, you can see it's 3. So that's the reason plus 3. And why plus 2 here? Because we need to know how many equations that are given. So we have 2 equations here that are given, the chemical equation. So that's the reason plus 2. And why minus 5? We need to know the number of independent molecule, which is bahagian output here. So ada 5. So that's the reason minus 5. And why minus 0? Because we need to know the other equation, which is we don't have any other equation. So that's the reason minus 0. So you calculate all of this and you will get 0. So this can be solved. So firstly, how to do it? You need to assume the basis first, which is we put it as a 100 for the basis. Here we need to calculate the C2H4. So we need to times that all the given with 100, which is the basis that kita assume. And you will get this, all the answer for C2H4, we're going to get 43.3 mole. For H2O, we're going to get 44.76 mole. C2H5OH, we're going to get 2.5. C2H52OH, and we're going to get 0.14. And the last one, inert gas, 100 times with 9.3, which is here, the given. And we will get 9.3 mole. Next, we need to know the consumption first. So consumption kita assume dia sebagai C2H4 reacted. So how to calculate C2H4 reacted? So C2H3OH produce, kita pluskan dia dengan consume punya. So 2.5 mole, kita plus dengan 0.144 mole times with 2 mole C2. Kat sini mana kita dapat benda ni? Daripada equation ni, nampak tak? So dia ada 2 mole, sebab tu kita letak kat sini 2 mole. Dekat bawah ni 1 mole sebab depan ni 1 mole. And then kita akan dapat dekat sini 2.5 plus 0.28 and the final answer we're going to get 2.78. So daripada C2H4 yang kita dapat ni, kita boleh kira guna molecular balance. So dekat sini kita kena tahu dia punya equation first. So equation for molecular balance kita dapat kat sini, input plus generation is equal to output and consumption. So input ni kita kena tengok dia dekat bahagian input flowchart. Generation kita kena tengok dia dekat bahagian chemical equation on the output side, and the output dekat sini we need to look into the output flowchart, and the consumption kat sini kita kena tengok dia dekat bahagian input chemical equations. We calculate the C2H4 balance first. So dekat sini the equation for C2H4 balance, no generations. So input is equal to output plus consumption. So we need to find the N1. So N1 dekat sini going to get 46.08. Kita dapat 2.78 ni daripada consumption. H2O we have input plus generation is equal to output plus consumption. Dan input tadi, kat bahagian input tadi dia ada N2. So N2 dekat sini kita assume sebagai N2 plus dengan generation dia dekat sini equal to output plus consumption dia. So kenapa dekat generation ni we do like this? Because we want to cancel out dia untuk dapatkan H2O. So nanti you akan dapat 47.54 minus with 0.14, you're going to get 47.4 mol. Inert gas balance, dia punya molecular balance is simple, just input is equal to output. So dekat bahagian input N3 is equal to output dia, dekat bahagian output kita ada 9.3 mol. So N3 dia is equal to 9.3 mol. So that's all for the B equation. So that's all from me.
Okay, question 4, dia bagi dua chemical equation. This is the first and this is the second. First adalah main reaction, yang bawah adalah side reaction. Dia dah mention dalam soalan. Soalan dia minta, carry out a degree of freedom analysis and calculate the molar composition of the reactant stream by using atomic balance approach. Degree of freedom dan molar composition of reactant stream. Apa-apa pun kita kena buat flowchart. Bila flowchart, kita tak miss out any information dan kita tahu apa nak kena cari. First sentence dia bagi, to feed to the reactor contains ethylene. Ethylene is your C2H4. Your steam is your H2O dan inert gas. Okay, feed tu adalah input in simple terms. So maksudnya feed to reactor, maksudnya di input kepada reactor. So kita lukis arrow masuk ke dalam reactor. Okay, and then you list out N1, N2, N3. Kenapa unknown? Sebab dia tak bagi mole composition for reactant. Tu lah kita nak kena cari. Kan ayat dia cakap a sample of the reactor effluent gas. Effluent tu maksudnya output. Maksudnya output gas is analysed and found to contain 43.3 mol. Okay, so sekarang ni effluent tu output. Output maksudnya product. Okay, so dia bagi molar composition product lah. Untuk ethylene, ethanol, ether, inerts and balanced water. So you boleh buat output, arrow keluar macam ni. Then you list out all the products of molar composition yang dia dah bagi. So balanced water nak cari macam mana? So we know that percentage has 100%. So you minus with total of the products yang molar composition yang dia dah bagi. Tambahlah this one, tambah this one, tambah this one, tambah this one. 100% minus with total, you will get water balance. So you should get 44.76. So now your flow chart is complete. Okay, kita dah boleh kira your degree of freedom, DOF. So setiap method ada formula tersendiri. Macam atomic balance, this is your formula. Kita will go through one by one. Number of identified label unknowns. So your unknowns is here, N1, N2, N3. So 3. So plus 3. Plus 3. And then second, number of independent atomic species. Atomic, atom. Okay, atom. So apa atom yang terlibat? Adalah C, H dan O. So we have 3. Okay. So tolak 3 sebab dalam ni memang simbol tolak. Okay. Third one, number of independent non-reactive molecular species. Bila kita cakap non-reactive, maksudnya dia tak menghasilkan produk baru. Macam ni, semua dihasilkan produk baru ni. Okay. Ni dihasilkan ethanol baru. Ni dihasilkan ether dengan H2O. Kosong lah. And then the fourth one is no other equation relating unknown variables. Yes, kosong. Sebab dia tak bagi macam extra information. Macam fractional conversion ke, dia tak bagi. Okay. So bila totalkan, you will get 0 for your DOF. Bila 0 indicates yang this question can be solved. Okay. Now kita dah boleh start calculate untuk molar composition of the reactant stream by using atomic balance. So kita buat balancing antara atoms yang terlibat. Dalam ni C, H dan O kan. Kita akan guna these atoms untuk cari unknown yang kita nak. Kita boleh tengok antara chemical equation dan flowchart. But I like to use the flowchart because it's more easier. Lagi jelas sebab kita laporkan information. Kita kena berpegang kepada input is equal to output. Okay. So kita ada 3 atoms kan yang terlibat C, H dan O. So let's say I want to use carbon first. So kita kena tengok dekat bahagian input ni, yang mana contains carbon. So ethylene kan. So we can put ethylene as our input. So buatlah N1 mol percent C2H4 darab dengan number of moles yang carbon tu ada. So C2H4 ada 2 carbon. So kita buat 2 mol carbon. And then sama dengan, okay, this is your output. Okay, so kita letaklah dekat bahagian output mana yang ada carbon. So C2H4, C2H5OH and ether. So letak molar composition and then letak dengan number of mole. So then you add up, you just buat you punya algebra calculations and you will get 46.08. So you punya ethylene N1 dah ada. Okay. Now we proceed dengan hydrogen balance pula untuk cari yang N2 dengan N3. N2 kita buat the same thing. Klik dekat bahagian input yang mana ada hydrogen. So ethylene and H2O. Okay. Ethylene is C2H4 so ada 4 mole of hydrogen. Okay, so boleh masukkan dalam ni lah. N2 sebab dia still unknown, darab dengan mole dia dan tambah dengan 46.08. Mana dapat ni? Dapat daripada yang kita dah calculate tadi. Darab dengan 4 moles of hydrogen. Let's calculate the output. output mana yang contains hydrogen, C2H4, C2H5OH, ether dan water balance. Water balance kita dah kira kan. Then kita just do the calculations at 47.4 mol. Okay. So kita dah ada N1, N2. Okay, as for inert balance, we will get N3 equals to 9.3 mol %. Inert gas dia tak participate dalam apa-apa reaction dalam ni tau. Okay, so bila dia tak participate, kiranya inert gas punya molar composition product kat sini remains the same as the input. Okay. Okay, so let's move on to question 5. A, disuruh draw and label process flowchart. Kalau kita nak draw flowchart, kita kena baca one by one. Assuming a fresh feed basis, feed tu adalah input, basis of 100 mol C3H8 into the process reactor. Maksudnya 100 mol C3H8 tu adalah input kepada reactor. So kita buat arrow masuk sebab dia adalah input. 100 mol C3H8 masuk reactor. Next, process is to be designed for a 95% overall conversion of propane. Maksudnya 95% conversion of this whole process is converted. Products from the reactor which contains H2, C3H6 and C3H8 leaves reactor. Dalam ni ada dua keyword, products and leaves. Dua ni menandakan ia adalah output. Leaves the reactor. So maksudnya H2, C3H6 dan C3H8 ni adalah output for reactor. And is fed to the separator. Tadi output, sekarang fed, sekarang input pula. H2, C3H6 dan C3H8 itu adalah output bagi reactor dan input bahagi separator. Okay. Is fed to the separator in order to be separated into two streams. Okay, separator ada dua stream. Ada dua output dan satu input. Dalam flowchart kena buat dua stream juga. First stream contains the product which includes H2, C3H6 dan 0.55% C3H8. So kita label siap-siap dekat sini. Okay. Second stream containing unreacted C3H8 and 5% C3H6 in the first stream is recycled to the reactor. Okay, kenapa ada unreacted C3H8? Sebab earlier tadi dia cakap 95% of propane C3H8 dikonvertkan. So maksudnya the remaining 5% itu adalah unreacted. Okay, that's why ada unreacted C3H8 kat situ. 5% C3H6 tu di recycle back to reactors. Kita buat arrow ke sini. So dia akan masuk balik ke reactor. So this is what your flowchart supposed to look like. Okay, so let us hop on to calculate compositions of the products. Maksudnya kita kena cari segala unknown yang ada dalam proses flowchart ni. So dia bagi 100 mol C3H8. C3H8 is your propane. Dia dah bagi 95% overall conversion of propane. What is this 95%? It's your F. F is your fractional conversion. So what is the formula of F? Formula of F is this. F equals to moles reacted over moles fed. So 95% of overall conversion over with 100, you will get 0.95. 0.95 itu adalah ratio bagi moles reacted C3H8 dan moles reacted fed C3H8. Fresh feed dia dah bagi 100 mol kan? Okay. So darab akan dapat 95 moles. But this is reacted. This is reacted. Bila dia dah bagi chemical equation kan? Sampai ni semua adalah 1 mol. So should be here is 95, here is 95, here is 95. Tapi remember 95% of overall conversion of propane. So we're not looking for that. Kita nak 5%, remaining 5% of propane. So nak kira remaining 5% of propane 100. Your input needs to minus with the reacted C3H8 tadi. So you will get 5 moles. So this is your remaining 5%. Your C3H8 will get 5 mole. Your C3H6 will get 95 mole. Then hydrogen, you will get 95 mole as well. Hydrogen gas, you will get 95 mole. Okay? Okay, ni semua dekat kedudukan after separator. Sebab bila kita buat flowchart mudah, kita boleh nampak mana satu input, mana satu output. Okay? Products from the reactor which contains H2, C3H6 dan C3H8. First stream contains the product. Product ni merujuk kepada products from the reactor which includes H2, C3H6 and 0.55% C3H8. Okay, 0.55% C3H8 ni adalah merujuk kepada ratio between C3H8 product stream dan C3H8 daripada output reactor. So 0.55% bagi dengan 100, you will get 0.0555, and 5 moles is the product stream of C3H8 compared to C3H8 from reactor. Calculate, you will get 900.9 moles. Okay, so kita dah ada for X1. Next, the second stream containing unreacted C3H8 and 5% C3H6 in the first stream is recycled to the reactor. 5% C3H6, kiranya 5% of 95 mole from product stream of C3H6. 5% over 100, we will get 0.05. So 0.05 by 95 mole, we will get 4.75 moles. The amount they recycled back to the reactor. Okay? Setakat ni je kita dah cari daripada unknown yang banyak-banyak ni. So untuk cari yang the rest, we can conduct balances. So let us conduct balances dekat bahagian separator ni. So I like to make myself flowchart mudah so that dia tak nampak serabut dan nampak messy. Dengan information kita ada, kita boleh cari unreacted C3H8. So macam mana kita buat input is equal to output. Input 900.9, output kita adalah 5 and C3H8 895.8 moles for unreacted C3H8. Kita boleh proceed cari yang X2 mole C3H6. Macam mana? So kita continue input is equals to output. We get 99.75 moles. Okay. Okay, untuk hydrogen X3 mole H2, kita still akan dapat 95 moles. Input is equals to output. Kalau output 95, input pun 95. Kalau input 95, output pun 95. Okay, so now for the last two unknowns. Ni nak menunjukkan yang bila separate tu dah separate into two streams, yang di recycle masuk back ke reactor tu berapa. 100 mol C3H8 with plus with 895.8 sebab dia masuk sekali. So we will get 995.8 moles. While for C3H6 remains the same sebab this is C3H8. So kita tak tambah dengan C3H6 lah. So bila dia recycle dia just masuk balik 4.75 moles juga. So that is it. This is the full working for this question.